Okay, so I'm going to go over the chapter 2 through 5 study guide right now. This is set up just like the test. Number 1 on the study guide will mimic number 1 on the test tomorrow. Number 2 will mimic number 2, so on and so forth. The test will be on Math Excel, these exact questions, but with different numbers. You may notice as I go through these questions that that the numbers will be different than what you saw because that's just the way Math Excel is designed. Everyone does the exact same questions verbatim, but the numbers are different. However, you should still be able to follow along. If you are having a hard time following along, please feel free to reach out to me with your questions. So let's go ahead and get started. The pie chart summarizes the genres of 125 first run movies released one year. Is this an appropriate display for the genres? Why or why not? The genre of a movie is a categorical variable. The genre falls into a category. So, what this question is really asking is a pie chart an appropriate display for a categorical variable, for categorical data? And if you look back in your notes from chapter 2 and 3, you'll notice that for categorical data, one of the possible visual displays of categorical data is pie charts. So the answer to this question is yes. And the only one that says that is B. Which genre was least common? Obviously, in a pie chart, that's going to be the smallest slice of the pie. In this case, that's the yellow, which is going to be the drama category, the drama genre. All right, and that is it for number 1. Number 2, we have a two-way or a contingency table here. This is all totaled out for us already, so we don't have to worry about that. Let's look at part A. What percent of all applicants were Asian? So in this case, that's going to be out of all the applicants, that's going to be 1,328. How many of them were Asian? 407. So 407 Asians out of 1,328 total. And we want to put the answer as a percent. And as it says here, we want to round it to one decimal place. So if I convert this to a percent by moving the decimal point two places over to the right, this is going to be 30.6%. 30.6%. Part B, what percent of the students accepted were Asian? Okay, so out of all of the students that were accepted, in this case, there were only 200 students accepted. So out of those 200, how many of them were Asian? 58. So 58 Asians out of the 200 accepted students. So 58 out of 200, that is going to be 29% on the dot. Okay. Part C, what this time, so this is going to be a little different. What percent of Asians were accepted? So out of all of the Asian students, so out of the 407 total Asians, how many of them were accepted? 58. So that's going to be 58 out of 407. And if we round that to 1, that's going to be, let's see, 14.3. So that 2 has to get rounded up to a 3. So 14.3%. Part D, what percent of all students, so what percent of all students were accepted? So what percent of all students? So out of all students, 1,328, how many of them were accepted? 200. So that's going to be 200 out of 1,328. Let's see, that'll be 15.1%. 15.1%. And that is it for number 2. Okay. Number 3, find the marginal distribution of blood pressure. Okay, notice this is totaled out already. So the marginal distribution of blood pressure, in this case, that's going to be the percentage breakdown along this margin here. In other words, out of the 483 employees, what percent of them had low blood pressure, what percent of them had normal, so on and so forth. So what percent had low blood pressure? That's going to be 98 out of 483. So 98 out of 483, and we want to round this to one decimal place again. So that's going to be 20.3%. 20.3%. Let's see, for normal blood pressure, that's going to be 235 out of 483. So that's going to be 48.7%. Okay. And for part C, that's going to be 150 out of 483. Okay, and that will be 31.1%. That 5 makes that 0 round up to 1. So 31.1%. Okay. The company claimed that this data proved that people, that's a typo, but the company claimed that this data proved that people getting older directly causes them to have higher blood pressure. Is this true? Choose the correct answer below. Okay, so in that same set of notes on chapter 2 and 3, one of the very last slides had that statement: correlation does not imply or does not prove causation. Okay, while this data may make it seem like that there is a relationship between how old someone is and whether they have high blood pressure or not, while it may seem like that, that does not necessarily mean that being old directly causes you to have high blood pressure. We, of course, know that there are other variables or other factors at play besides how old you are. So the answer is no, this is not true because there are other variables at play. So just no, so it would have to be B or D. Now, B contradicts what I just said. No other variables linked to both. No, the point is there are other variables besides how old you are. So B can't be the right answer, so it's got to be D. No, because only a controlled experiment can isolate the relationship between age and blood pressure. So in order to prove a cause-effect relationship, you have to do a scientifically controlled experiment, basically like your classic scientific method. Okay, so that is it for number 3. Okay, number 4. The histogram shows the sizes in acres of 49 vineyards. Is this distribution uniform, unimodal, or bimodal? Okay, so uniform means that the histogram stays at roughly the same height. Clearly, this doesn't. Unimodal means it has one high point or one mode. Bimodal means it has two high points or two modes. This histogram clearly has one high point, namely all the way to the right here. So this is going to be a unimodal histogram, the unimodal distribution. Okay. Is the distribution symmetric or skewed? In this case, this histogram is clearly not symmetric, so it's definitely skewed. The question is it skewed left or skewed right? The direction of skewness, in case you forgot, always is the direction that the data tails off in. In this case, the data tails off to the left. So we would say that this histogram or distribution is skewed to the left. Which of the following best describes the center? Okay, so in our notes on chapter 4, we talked about the two main measurements of center are the mean and the median. Okay, now the question is, which one is most accurate? In the notes, we talk about that if it is symmetric, if the data is symmetrical, then the mean is most accurate. In this case, the data is skewed, so the median is most accurate. So the center is best described as by the median. So it's got to be A or C. In this case, it's going to be A, because we already said it's skewed to the left. It's best described by the median since the distribution is skewed to the left. And if you look, it does have an outlier off to the left here. So it does have an outlier. So the answer is A. What is the spread? In other words, what's the low number? What's the high number? Okay. So let's go at the high number first. It looks like these tick marks go up by 30. So this is 120, 150, 180, 210, 240, 270. So the high number is going to be 270. Okay. And the low number is going to be 0. Okay. So the spread, the acreage ranges from 0 to 270. Describe any unusual features. Okay, unusual features means gaps or outliers. In this case, there's an outlier mainly on the low end. So this outlier here is way lower than most of the data over here. So which one of these makes most sense? There are no unusual features, no. Most of the vineyards have close to the same number of acres. Well, this clearly shows not. So the answer is C. There is one vineyard that has considerably fewer acres, 0 to 30, than the rest. That's an outlier on the low end. So the answer is C. Okay, and that is it for number 4. Number 5. The histogram to the right shows the amount of oil produced in gallons from an acre of land in the country for 44 different crops. Which summary statistics would you choose to summarize the center and spread in these data, and why? Okay. So I talked about it was either the last question or 2 questions ago, particularly with center. Okay, when the data is symmetrical, the mean is most accurate. When the data is skewed, then the median is most accurate. And we have something similar for spread. The 2 main measures of spread are the standard deviation and the IQR, the interquartile range. Okay, when the data is symmetrical, standard deviation is most accurate. Okay, when the data is skewed, then the IQR is most accurate. So in summary, and I'll say this again, if the data is symmetrical, then mean and standard deviation are most accurate. When the data is skewed, median and IQR are most accurate. Now, in this case, is this data symmetrical or skewed? Well, this looks pretty skewed to me. It's definitely not symmetrical. It's skewed. This time it's skewed to the right. So because it is skewed, then the median and the IQR are going to be most accurate. So in this case, that answer is B, the median and IQR, because the distribution is strongly skewed. All right. Histogram shows the lengths of hospital stays in days for all female patients admitted to a certain hospital with a primary diagnosis of acute myocardial infarction, otherwise known as a heart attack. All right, describe the shape of the distribution. Is it uniform, unimodal, bimodal? I see one high point here. That has one clear high point, so that is definitely a unimodal histogram. All right. Is the histogram symmetric, skewed to the left, or skewed to the right? That looks pretty dang close to symmetrical to me. Okay, so the answer is C. Okay, what is the center of the histogram? Okay, when we talk about the center of a histogram, we don't mean the literal center. The center of the histogram is always where the high point is. Now, in this particular case, because the histogram is symmetrical, then the center is going to be in the literal center here. That's not always the case. If the histogram is skewed, then the center is not going to be in the literal center. So to sum up, the center of a histogram is where the mode is, where the high point of the histogram is. So this is going to be where the center is. So let's just check here. That's going to be 1, 2, 3, 4, 5, 6, 7, 8. So the center is at 8. Okay. What is the spread? Okay, the spread, remember, that is the low and the high number. So the low number is here. That's going to be 0, 1, 2. And the high number is at 14. So the spread is from 2 to 14. Describe any unusual features. Are there any gaps or outliers? Clearly not in this case. There are no gaps and no outliers. So therefore, there are no unusual features. Which choice says that? C. None of the data are significantly different from the other data. Therefore, there are no unusual features. Which summary statistics would you choose to summarize the center and spread in these data? Choose the correct options and explanation below. This goes back to what I said before, and I'll say it one more time. If the data is symmetrical, okay, mean and standard deviation are most accurate. If the data is skewed, then median and IQR is most accurate. In this case, we have already established that this is symmetric. So therefore, which summary statistics would we use? We would use mean and standard deviation. Okay, so which choice makes the most sense? D, the mean and standard deviation, because the distribution is roughly symmetric. And that should be it for number 6. Okay. Number 7. In March 2006, 16 gas stations posted these prices for a gallon of regular gasoline. What is the mean of the entire data set? So remember, I will review how to do this now. In order to find the mean, we want to go to our Google Drive and we want to open up a spreadsheet. And I will show you a little trick here on Math Excel. So we have our list of data. Now you could just type each of these in individually, but why waste the time if there's a shortcut? If you click right here, on this box here and click on Copy to Clipboard, this comes up, and all you're going to do is on your keyboard, you're going to hit Control-C to copy, and then you're going to go to your spreadsheet and you're going to hit Control-V to paste. And you have now copied and pasted all of the data into a spreadsheet. So I will show you this one more time. So on Math Excel, click on this box here and click on Copy to Clipboard. And then all you do is you hit Control C on your keyboard to copy, and then go to your spreadsheet on Google Drive, Google Sheets, and you hit Control V to paste. Okay. So what is the mean of the entire data set? So we want to find the mean. Okay. So to find the mean, remember on Google Sheets, we hit equals average. So equals average. And then after we select that, we're going to, with our mouse, we're going to highlight and drag all of the data here. Okay, so equals average. I hit enter, round to 2 decimal places. So the mean is going to be $2.31. $2.31. Okay. What is the standard deviation of the entire data set? So remember, to find the standard deviation, I'm going to go to a different cell here. And I'm going to do the same thing, except I'm going to type equals stdev. So equals stdev, and I can select standard deviation. And I'm going to do the same thing with my mouse. I'm going to drag my mouse, and I'm going to select all the data here. And I'll hit enter. And then just make sure we round to the correct number of decimal places. So the correct number would be 3. So that's going to be 0.080. If I round to 3 decimal places, 0.080. Okay. What is the mean of the data set with the 2 highest prices removed? And what is the standard deviation of the data set with the 2 highest prices removed? So I need to essentially take out the 2 highest prices here. Now, the cool thing about Google Sheets is that I can delete the 2 highest numbers, and the mean and standard deviation will automatically adjust. So let's see what my 2 highest numbers. I think it's 248. Okay, 248 and 245, I believe, are the 2 highest numbers. So I can delete 248 and I can delete 245. Okay, so let me just see here. If I put those back in, notice it goes back to where it was before. But if I delete those 2 numbers, it automatically adjusts, which means I don't have to go through that process again. It automatically adjusted. So the mean of the entire data set, rounded to 2 decimal places, is going to be $2.28. Okay, $2.28. And then the standard deviation, okay, round to 3 decimal places, that's going to be 0.055. 0.055. Choose the correct comparison below. So let's look at our answers here. Okay, so let's first look at the mean. So the mean went from 231 down to 228. So the mean of the entire data set is going to be 3 cents higher than it is down here. So if I look at my choices here, right, again, the mean of the entire data set is 3 cents higher or 3 cents greater. Okay. So by process of elimination, that means it's either got to be B or D. The mean of the full data set is about 3 cents greater. Okay. So now let's look at the standard deviation. Okay. If I look at the standard deviation of the entire data set, notice it's between 2 and 3 cents higher. So the mean of the the standard deviation of the entire data set is higher than it is once I take out the 2 high prices. So which one is that going to be? That's going to be B, it looks like. The mean of the full data set is about 3 cents greater. That's true. And then the standard deviation of the full data set is about 2.5 cents greater. 0.080, 0.055. That looks right to me. So the answer in this case is B. Okay, so that is it for number 7. Let's see, number 8. A wholesale food club charters all users a basic monthly fee and then adds on extra charges based on usage and other services, resulting in different fees for various users. They compile data recording each user's bill. Suppose they raise the basic fee by $3 a month. Which of the statistics in each group will stay the same? Which will change and how? So we have min, max, and range. Okay. So what they're asking is if I take each number in the data set and I add 3 to it. So no matter what everyone's bill is, they're all going to go up $3. So I'm adding the same amount. If you look back in your notes from chapter 5, if I add the same number to all numbers of a data set, then that means the min and the max are obviously going to go up by $3. But is the range going to change? Remember, range is max minus min. So if the max and the min both go up by the same amount, is how spread out they are going to change? And the answer is no. So which choice makes sense? So min and max are both going to change, but the range, how spread out they are, is not going to change. So let's see which choice makes most sense. Looks like D. Both the min and the max will increase by the same amount. Okay, in this case, they will increase by $3, which means that the difference between them will not change, and therefore the range will not change. If everything goes up by the same amount, then how spread out they are will not change. So the answer in this case is definitely D. Okay. All right. So that is number 8. And now we are up to number 9, last question. So similar concept here. A music downloading service charges all users a basic monthly fee and then adds on extra charges based on usage and other services, resulting in different fees for various users. They compile data recording each user's bill. Suppose they raise their rates by 7% for everything. How will that increase affect each of those statistics summarizing customers' monthly bills? So they are raising their rates by 7%. Okay. The key in this case is that they're raising it by a percentage and they're not just adding the same exact number. So because everyone has a different bill, a different amount for their bill, 7% of my bill is going to be different than 7% of your bill, than me, and 7% of someone else's bill. So the amount that each person's bill increases by is going to be different because the amounts are different. So not only are the min and the max going to increase, but how spread out they are, the range is also going to increase because we don't know what the amount, what 7% of everyone's bill is. So if the min and the max increase by different amounts, then that means the range is also going to increase. So let's see which one makes the most sense. I think the answer in this case would be A. Let's look at A and make sure that makes sense. Both the min and max will increase, but they will not increase by the same amount. That makes sense. 7% of the min is going to be different than 7% of the max. Okay, so they will not increase by the same amount. This means that their difference will change, causing the range to change. So the answer in this case is indeed A. Okay. And I believe that is it for our study guide. Make sure you reach out to me if you have any questions. Like I said earlier, this will be exactly what your test will look like. It will be on Math Excel. Will just like this, literally the same questions, but different numbers.